So yesterday while you were working on the quick review for log laws, on that page there was 3 examples given to you with instructions, and then you were supposed to solve the questions on the back. The 3 examples that were given to you, I am going to go through them with you right now. And so you don't need to write notes because they're on that sheet. So these first ones you can just watch and see if you can understand. Okay? So the reason that we first learned our log laws and practiced working with them is so that when we get to equations like this, we have the tools to be able to manipulate and to solve. So this first one can be solved in 2 different ways. I'm going to show you the standard solving method that we're going to be using all the time first. And then I'm going to show you that sometimes there's shortcuts, but we're going to want to use the standard solving one as much as possible. The standard solving one is if you're solving for x in an exponent. At the beginning of this unit, we could only do that if the numbers were in the same column in our powers chart. Do you remember solving ones like this? 4 to the x equals 32 to the x minus 1. Right? In this case, what would you have to do? You'd have to change the 4 to the 2 squared, 32 to 2 to the 5, you're in the same column, and then you would get 2 to the 2x equals 2 to the 5x minus 5. And we did this, so 2x has to equal 5x minus 5. 3x equals 5x is equal to 5/3. So we solved exponential equations at the beginning of this unit only if the bases could be made the same. But now we're going to get into questions like this one, where you can't make the bases the same, because 2 and 3 are not on the same power structure. So this is where logarithms come into effect, because logarithms solve for exponents. So if you're solving an equation where x is in the exponent, and you can't do it by making the bases the same, you're going to need logarithms. And on your calculator, you have a log button, and you have a natural log button. And they're used interchangeably. So we're going to start this one by saying, I'm solving for x in an exponent. What if I take the logarithm of both sides? What I do to one side, I do to the other side. And the reason this is really helpful is you want to get the x by itself, and logarithms give you a log law that lets you take an exponent and bring it out in front. So if I do that, then I would have the x out in front, and this is basically like solving 2x equals 3. These are just numbers. Log of 3 is a number. It's 10 to what exponent is 3? 10 to what exponent is 2? They're numbers. So if I wanted to get x by itself, I could divide both sides by log of 2. To my calculator now. Wait at least 2 minutes. And then think, did I not push it hard enough? And then, I think I pushed it. Yes. Because if you push it hard enough the second time, it opens up 2 of them. So, on all calculators, whether you have a graphing calculator or a scientific calculator, your calculator has a way to store an answer into memory. And if you can store your answer into memory, we're going to be able to check. This is one thing I love about the logs unit. You can check if you're right. You love it if you check if you're right and find out you're right. Okay? It's not so much fun when you check and it didn't work, and then all I know is something went wrong somewhere. That's maybe not as nice. So we're going to type into our calculator log of 3 divided by log of 2. Push enter, we get 1.58. On the graphing calculator, the store button is right above the on button. So I'm going to store it, and I just like to use X. You can use any letter. You can do alpha, A, B, C, D, any letter you want, but I like to use X because it's convenient. And I now stored 1.584962.501 plus another 16 digits. into the calculator. My original question was 2 to the power of x. So I can now write 2 to the power of x. If I push enter and it equals 3, then I know I did it right. If I push enter and it doesn't equal 3, then I know I did something wrong. I push enter, it equals 3, relief, and we've checked our answer and we know that it's right. Okay? Now, this is the standard way to solve it. And you can take the log of both sides, or you could have done the same question by taking the natural log of both sides. The same rule applies. And in the end, can you see that everything would have been the same, except instead of log, I would have natural log. And sure enough, if I go to my calculator and I use the ln button, ln of 3 divided by ln of 2, notice it comes out to the exact same answer. So whichever log you use, log base 10, log base e, that's the natural log, or any other log base, although they're not recommended because they're not easily accessible on your calculator. Okay. The other way, the shortcut way for this one, is only available if your calculator allows you to type in other bases. So this is what is normally taught because 90% of calculators only have log and natural log for scientific calculators. But can you see that you could just change this to log form? If I write this as a logarithm, the base is 2, the answer is 3, exponents are always what they solve for. So if I change it to log form, I get x equals log base 2 of 3. So if your calculator allows you, this is really short to solve, if your calculator allows you to do the log base 2 of 3, you get 1.5849 again. So there's many ways to get that same value. To find the log base, if you have the fraction button by doing alpha y equals, you can move over to the window and it has a log base. The log base, if you have it, is also located in the math button, but past number 9, so you don't see it right away, but it's available on your calculator. If you have the TI-83, it will not be on there. Then you have to do it the other way. So the TI-84, if you've got the updated system, will have it. Okay, so let's look at example 2. Again, this is on your sheet, so you don't need to write anything down. Again, there's going to be multiple ways that you can solve this. Okay? I'm going to show you a couple of different ones, depending on what you decide to do first. Okay? My recommendation for this one is if you can get the power by itself, which in this case would be easy, I could divide both sides by 2. That makes your life easier. So in this case, if I divided both sides by 2, I would get 3 to the x equals 5 over 2. This is not how it's solved in your notes, so this is a different method. Okay? I will solve it as it's in your notes next. Can you see at this point, you could take the log of both sides, log or natural log. If I took the log of this side and the log of this side, this would say, hey, that allows me to use the log law to bring the exponent out, which is the whole purpose. You're solving for x. So the fact that you can bring this x out in front, now let's just divide by log of 3. Again, we'll go to our calculator and type log of 5 divided by 2 divided by log of 3. Again, if you have the fraction button, it's good to use the fraction button because then you can do log and make it look exactly like you've written it. Either way, you get the same answer. Again, I'm going to store this as x. It just replaced the x that I had stored before. And it doesn't matter what your x is stored at. It doesn't affect your graphs or anything else. It's just something that it has in its memory. So I stored it as x, and now I can go back to my original equation, which was 2 times 3 to the x. And if everything works out, this should equal 5. And it does. So then we know that you're right. Okay? 0.834. So x equals 0.834. Now most students, okay, get so excited about taking the log of both sides, sometimes they do it right away. So in method 1, I did what I do to one side of the equation, I do to the other, divided both sides by 2, just to get the power by itself. But sometimes, and I think this is what I have in your notes, students get so excited about taking the log of both sides, they do it right away. Which is perfectly fine. However, you have to be careful here, because order of operations and log laws have an order of operations come into play. Students want to take this x out in front. According to the log law, and the log laws are very particular, it has to fit the log perfectly in order to do it. The log law says if you have an exponent to the entire big M inside the brackets, then it can come out in front. And our exponent currently, can you see that that exponent is just to the 3, not to the 2? So we would not be allowed to bring this x out in front. Instead, we have to consider the fact that there's multiplication in between first. And you have a log law for that. If you're multiplying two things, your log law says you can add. So I could do this first, and then now that exponent is allowed to be brought out in front. So I can bring that exponent out in front. At the same time, I'm going to move the log 2 to the other side. Log 5 minus log 2. And then get x by itself by dividing everything by log 3. Basically, log something, log base 10 of a number, is a number. So really what you're doing here, this should be no more difficult than if you were solving that in grade 9. It just becomes more difficult because the numbers no longer look like standard numbers, right? Log 3 doesn't look like a standard number, but it's equal to something. It's like 0.2 or okay? So I can type this into my calculator, use my fraction button. I have log of 5 minus log of 2 divided by log of 3. And I got exactly the same answer, 0.834 from before. And some of you might even notice that, hey, there's a log law for subtracting. What is it? It's dividing. You notice that's exactly the same thing I have on the left. I have the dividing. It's just where you decided to do your log laws. Log laws are allowed. Those things are the same. Why do I recommend the blue? Because here you're going to be tempted to do something that's not allowed. This way, there's no temptation to do anything that's not allowed. But you still need to know all of your log laws. Okay? And then the last one in purple, can you see that if you got the power by itself, that I could just, the base is 3. You could just change that to a log base 3 using the definition. And then that would be really quick. Type that into your calculator. You would get 0.834, but that only works if you have the log base. Log base 3 of 5 divided by 2, which is 2.5. Oh my goodness. We get the exact same answer. So multiple ways of solving this. Okay? Now, Because of this shortcut being so short, and it's not really fair that some students have that on their calculators and others don't, most often these questions end up looking like this, with x's on both sides, in which case that shortcut doesn't work. Okay, so what do we need to do? We need to take the log of both sides. I am going to, now, I'm going to use the natural log this time. This doesn't matter, log or natural log. Okay? We've got x and exponents. I'm going to take the natural log of both sides. As a mathematician, I like the natural log for a couple of reasons. But very practical. It's one less letter to write. Log, L-O-G. Natural log is L and N. You will save yourself about 4 to 5 milliseconds at the end of this question by not writing one letter. Right? Although, if you're reading it, when you have log, people just say log of. When you have natural log, you sort of have to say natural. So it's harder to read. It's just longer to read, so I don't know. Anyways, I now have this exponent is to the entire thing. It could come out in front. This exponent is to the entire thing. It could come out in front. But when I put it out in front, I need to put it out in front with brackets because it multiplies by natural log of 5, and since natural log of 5 is a number, we're going to have to distribute So what I did here is I distributed the natural log of 3, I distributed the natural log of 5. And what makes this one difficult is, or more difficult, is we have x's in more than one place. We have x's on the left side and we have x's on the right side. Okay? What would you do if you had numbers and x's on different sides in a grade 9 question? You put all your like terms together, right? So we're going to do the same idea as grade 9. We're going to put all of our x's on one side, all of our numbers on the other side. The only thing that's different is in grade 9, you put the minus 3 on this side, you'd be like, oh, I can combine that to get minus 10. In grade 12 with logarithms, it's not so easy to combine. So we just leave it separate. But I'm going to put all my x's. So I have x natural log of 5. I'm going to move this one, minus 2x natural log of 3. I'm going to put those x terms on the left. I'm going to put the numbers, which I have 3 natural log of 3, and add natural log of 5 to the other side. I'm going to put my numbers on the other side. Now, with the numbers in grade 9, you would have 2x minus 5, and you would have seen those as like terms and put them together. This, not so easy mental math to just go, oh, I'll put those together. So we do something also that we've learned in the past, is you can factor out. Like, if you couldn't do 2 minus 5 and get minus 3, you could factor it out and go, it's going to be 2 minus 5. I'm just going to leave it like that, even though you know that that's minus 3. We can factor out, and that will be the key when you have more than one x. You can take an x out of this side. If I take an x out of this first term, can you see that what would be left would just be the natural log of 5. If I took an x out of the second one, I'd be left with the 2 and the natural log of 3. The x would be gone. It's equal to. Now that is a number, and what's in the bracket on the left is a number. Though we don't know really what that number is, we can get x by itself by dividing. And at this point, you might realize why I decided to use that. Like, how many letters did I save using natural log over log? Like, I probably have carpal tunnel if I was teaching with log terms. But we can take this whole thing into our calculator. And again, I'm going to use that fraction button. If you don't have a fraction button, When you have more than one thing on the top and more than one thing on the bottom, you're going to need to add extra brackets when you type it in. So I have the fraction button. I don't have to add those extra brackets. I can just go 3 natural log of 3 plus natural log of 5 divided by natural log of 5 minus 2 natural log of 3. Push enter. Negative 8.34. I'm going to store that as x because I'm not sure if that's right. I'm hopeful that is negative 8.35. But I've stored it as x, so I can go back to my original equation, which was on the left 5 to the exponent of x minus 1. Again, if you don't have a calculator that puts it up an exponent, you're going to have to put that exponent in brackets. I push enter. That's equal to 2.93 times e to the minus 7. On the other side, I type in 3 to the 2x plus 3. If this matches up to also 2.936 e to the minus 7, then I know that I've got it right. There's like, adrenaline rush right now because on the video this could be bad, right? Spend the next 20 minutes trying to find our mistake. Oh, it worked. Good. So you can check your answer to find out if you're right, which is really helpful. That's why on the back sheet when it's exercise 1, there was no answers given. Because once you found your answer, I said, I could give you the answer, but you should learn how to check it, because then it's more powerful. Because that's not cheating on the test. Be like, sorry, Mr. Jarrett, I cheated, I checked, I'm right. I know what I'm doing. Can you just give me a 0 for cheating? No. Okay, so this is almost the hardest one with x's on both sides. The only way that I can make it harder would be to add numbers. Okay? What's 2 times 3? 6. Can you put that together? No. But you are so good at 2 times 3, you will be tempted to write 6. But order of operations say you have to do exponents before you multiply. So you'll be tempted to multiply, but technically you're not allowed to because of this exponent of x plus 1. So the only thing we could do on this one is take the log of both sides. And to save a letter, I'll do the natural. So this is the new one. I just made this one up. And the second temptation is that you're going to be tempted to bring the x plus 1 out in front, but you can't because that x plus 1 is only an exponent to the 3. You first have to recognize that there's multiplication. So we have to use the log law for multiplication, which says if you're multiplying inside logarithm, you add. So I add natural log of 2 plus the natural log of 3 to the x plus 1 equals natural log of 7 plus natural log of 5 to the x minus 1. And now, bring it on front. And so there are some students who see that that's what's going to happen, and you might be one of them, that you would, okay, and since it's more than one thing, we have to put it in brackets. Can you see yourself maybe just going from this step to this step? Could you do that in your head? You do the adding and you bring the exponent out in front right away. Okay. On the provincial exam, that step is worth 2 marks. Because there's 2 things, there's 2 log laws that you did. And generally the way that grade 12 or math marking works is if you do a step that's something that you learned in that grade year, like you learned logarithms and all the log laws in grade 12, then that step is worth a whole mark. If you do a step of something that you did in previous grades, it's usually worth only half a mark. So from here to here, you use 2 log laws, that would be 2 marks. Okay? Then, watch the following. Now, we're going to have to distribute, right? We can distribute this. We can distribute this. We would get natural log of 2 plus x natural log of 3 plus natural log of 3 equals natural log of 7 plus x natural log of 5 minus natural log of 5. I've distributed. I have two terms with x's. There's an x here and there's an x here. I'm going to put all my x's on one side. So I'm going to subtract the x natural log of 5. I'm going to put all my numbers on the other side. So I had natural log of 7 minus natural log of 5. And now I'm going to move the natural log of 2 over. And I'm going to move the natural log of 3 over. Factor out the x. Look how many letters I'm saving by using the natural log. I mean, this one, so much time saved. And now you could get x by itself. By dividing by the natural log of 3 minus the natural log of 5. Okay? All of this work from this point to this point uses grade 9 math. Putting x's, factoring out an x, combining like terms. All of this work on the exam is worth half a mark to get x by itself. 2 marks for that one step, that was relatively easy. And then all of this stuff, because it's considered stuff you already know, is worth half a mark. And then getting the answer on your calculator would be the last half of a mark. So let's see if we can type this into our calculator. I'm going to put it there so I can actually see it while I'm typing. Use my fraction button. Natural log of 7 minus natural log of 5 minus natural log of 2. Notice that on my calculator it adds a bracket, kind of annoying, because then you have to close that bracket. Just be careful with that. Natural log of 3 minus natural log of 5. 2.84, store it as x. And I'm going to check if I got it right. So on the left side I had 2 times 3 to the exponent x plus 1. Enter. 137.22. 7 times 5 to the exponent x minus 1. How many of you are actually hopeful it doesn't work out? Kind of a little bit, kind of wishing. I was bad that way. I was, as a student, I enjoyed when things went wrong for the teacher, when, you know, it was like, field trip today, and it was raining, and I was like, how are they going to deal with this? This is going to be a disaster. And I don't know. It's terrible that I enjoyed that so much. So I guess now as a teacher, I'm a little bit nervous pushing that enter button. Oh, it worked. So we know that we got it right. Oh, it's like once I sat with my cousin, and she was just as bad as me. And we were at a presentation, and the person who was going to be speaking to all the students had a music stand to put their papers on. But when they got to the front, the music stand was too low. Okay? And it was a little bit stuck. So they pulled and it didn't lift up. They pulled a little bit harder. What do you think? It came straight up, right between the eyes, a little cut, bleeding while the presentation. And did you think we sat there nicely and listened, or do you think we giggled the entire time? Or the kind of giggle where you're trying not to giggle, right? And your whole body is like shaking while you're trying to hold back anything coming out of your mouth. So bad. I should have been like, oh, are you okay? But no, I enjoyed it. So let's turn to page 420 in section 5.7. Maybe that's why I'm so calm when my computer has been so bad, because I know that as a student I would have enjoyed the problems that the computer would have had. And so I know that it doesn't pay but to be patient and wait. All right, page 420. Solving each of these. Can you see with the first one, if you have to change a base, that's the quickest. You could, in A, do that right away and just write log base 4 of 12 equals x. Boom, type it into your calculator, and you're done. However, if you don't have the change, you're not allowed to write that into your calculator, then it makes sense to take the log of both sides. It's not hard. You get to bring the x out in front. Divide both sides by log of 4, and you get the same answer anyways. Log of 12 divided by log of 4. Then again, you can store that as x, and you can check that 4 to the x is 12 to know for sure that you got it right. Mental math-wise, can you see that the answer should have been between 1 and 2? That 4 to the exponent of 1 is 4, and 4 to the exponent of 2 is 16, and you want to find 12, you should get an answer between 1 and 2. Sometimes it's nice to have that kind of estimation skill to see if you're on the right track, right? But that's not to say that sometimes in mathematics I get people who answer a question like this, 12 equals 4 to the x equals 8,000. I get answers like that. I'm like, did you even look at the question? 4 to the power, 8,000 4s all multiplied together. You think that's equal to 12? Really? Right? So it's sometimes nice to have that mental math estimation there just so that you don't say something that's ridiculous. I mean, we've all said things that are ridiculous in our lives. I mean, I just say that. But, all right, part B. Part B, when you only have the x's on the one side, we only have the exponent on the one side, I would say you're going to have an easier time if you take the time to combine like terms or divide both sides by 3, get the power by itself. And you see this one works out nicely. I can just divide both sides by 3, and then I get 12 equals 2 to the x plus 1. So much easier to work with if I take that time at the beginning. Okay? Now, if you take the log of both sides, you'd have log of 12, and on this side, the x plus 1 would come out in front. You can do that step, right? It was up here, and then it just came out in front with the log law. We'd have to distribute the log 2 Get x log 2 plus log 2. Put all of our numbers on one side. And divide by log of 2. Can I cancel those log 2's? No. Because this is subtracting this like grouped as one factor. The only way you can simplify or cancel factors is if they are identical. And in this case, they were not. Type this into our calculator. Again, use brackets if you don't have the fraction button. Log 12 minus log 2 divided by log 2. Store that as x because I want to check if I got it right. My original question was 36. 3 times 2x plus 1. 3 times 2 to the power x plus 1. I get 36. I'm happy. It all works out. Okay. Check this out. If you wanted to change it to exponential form, or like to log form right here, and use the base, this would be log base 2 of 12 equals x plus 1. Uh-oh. We have an x plus 1. It's not just an x. But can you see you just subtract 1 on both sides? So then x would equal log base 2 of 12 minus 1. And I mean, there's apps where you can just take pictures of this stuff, right? And it just solves it for you. Yeah, I can do that. Yeah, my son was showing me an app that not only does it solve any math question you want, it like said, could you write me a 1,000-word essay on this topic? And it does. Crazy. Could you write me a song? It's like, and apparently it doesn't. It's AI and random. It's not like copying from somewhere. So if you say it's going to change education like crazy, like you could write it. You could ask it to write a song. Okay? You could write a song. I will come with lyrics about Jeremy in math class. And then you could say, oh, this is a good song. Add a verse about Jeremy in choir, and then would add that in there, and then I will bring that song, and Izzy will sing it for us. Do all sorts of crazy things. Okay, part C. Right. It's kind of ironic, because with apps like that, that means really smart people are making things so that other people can't get smart. Kind of. And then if they're not smart, then you could just say, oh, you have to pay for this app. Okay.
How do you do like the predictor calculator? I'm getting like different numbers.
So you might, let me just check what you tell me. Yes. So you, because you don't have the fraction button, you need to make sure you add these extra brackets to group the top together. Because if you don't add those brackets, technically what you did is you wrote log of 12, and then you hit the subtract sign, and then you wrote log of 2, and then you hit the divide sign and says, oh, we should divide just this one by log of 2, instead of the whole thing by log of 2. So your calculator is smart, and it will tell you, it will do what you tell it to do. But it doesn't always do what you want it to. Sometimes you tell it to do something you didn't actually want. And so the last one is 3x plus 1 equals 6x. This is one with x's on both sides. Okay? You wouldn't be able to do the shortcut. You can't use the just change with the definition of a logarithm. You have to take the log of both sides. We have x's on both sides. These ones are a little bit longer, but you might do this and get 2 marks all in one step. 1 mark for knowing you have to take the natural log, the other mark for bringing the exponent out of sight.
So like, like
No, you can't with x on both sides because of order of operations. You're not allowed to divide the 6 and separate it from the exponent. I know it's tempting. You'd like to do that, but it doesn't allow you. So then I have x natural log of 3 plus the natural log of 3 equals x natural log of 6. I'll put all my x's on one side. Put my numbers on the other side. And it doesn't matter which side you decide. I had done all my x's on the left-hand side, so I did it again, although if I was doing it myself, I probably would have done all my x's on the right-hand side. It doesn't matter. Factor out your x. And again, you would need to have these extra brackets on the bottom if you're typing it in without the fraction button. It's always good to see if you can type these in yourself so that you know whether or not you would get the same answer. 1.58. So now I'm going to store that as x and check. I had original question here. 3 to the x plus 1. And 6 to the x on the other side. I wasn't as nervous on that one. I was feeling already like confidence was up. Thought I was going to get it right. Scroll down for those of you that are. And this is like everything that we did, all of our log laws. This is main purpose number 1, was to solve equations like this that prior to grade 12 you weren't able to solve. Okay? Prior to this unit, the only way you could solve this would be with Desmos. You could have put this into y1 and this into y2, and then saw where the graphs intersect. But you didn't have an algebraic way of figuring it out. Okay, questions for practice. 7, 8, 10, and 12.